Hello everyone, my name is Pawan and welcome to my channel. So today we are going to learn about interval estimation for sigma unknown case. So let us start today's video. We know that previously we learned about the sigma known case wherein sigma means standard deviation which was given to us in the particular problem. Okay. Now in this case the problem will not give us the standard deviation. Okay, so what we'll do, we'll either calculate the sample standard deviation with the help of a formula, and we will denote it by smaller s. The sample standard deviation is denoted by smaller s. So we will calculate this with the help of a formula which we have summation of xi minus x bar divided by n minus 1. So x is the number of entities or observed data and x bar is our average or mean, n is our sample, and we subtract it by 1. So similarly, what is sigma unknown case? If a good estimate of the population standard deviation cannot be obtained prior to sampling, we must use sample standard deviation S to estimate. This is what I told. The S, which is sample standard deviation, can be used to determine the interval estimation. Such case is called a sigma unknown case. So we don't have a sigma, we'll have to calculate the sample standard deviation. When S is used to estimate, the margin of error and the interval estimate for the population mean are based on the probability distribution known as the t distribution. So when sigma is unknown, in our case, what we do is we use t distribution table. Okay, so we will understand what is t distribution in the next slides. The t distribution is a family of similar probability distribution with a specific t distribution depending on a parameter known as degrees of freedom. So in order to find out the estimated t distribution, the value of it, we will need degrees of freedom. So how do you calculate degrees of freedom? We subtract n minus 1 and this gives us degrees of freedom. As in this diagram, what is degrees of freedom? We can see this is 10 degrees of freedom, this is 20, meaning that the sample size is 11, and in this case the sample size is 21 for 20 degrees of freedom. Moving on. Now we know that in the sigma known case, we use margin of error as said alpha by 2 into sigma divided by root n. This was for our sigma known case, but in the sigma unknown case, we use t alpha by 2 into s divided by root n. The sigma is getting replaced by s over here in this case. Other things are same, so in order to estimate the interval, what we do? We calculate the upper limits and lower limits. So x bar plus t alpha by 2 into s divided by root n. This thing is called as our margin of error. In this case, x bar minus t alpha by 2 s divided by root n. Same. Okay. Now moving on. So this topic was very short and simple. We seen that we have a case which is called as sigma unknown, where standard deviation or population standard deviation is not given to us. Okay, it is not given to us. That is why we are calling it as sigma unknown, because sigma is unknown in our cases. So we have gone through some terminologies, which is confidence interval, confidence level, margin of error, and in the case of sigma unknown, what we do is we use the T distribution table. We did not use the Z table. Okay, this is always and always you have to remember it. We also understood about upper limit and lower limit, which is same for everything. Now let us understand this problem. For a T distribution with 16 degrees of freedom, find the area or probability in each region to the right of 2, 1, 2, 0. Okay. So let's understand this, what it is saying. A, which says right of 2.21, 1 to 0. Okay. So here is our T distribution table, and they were asking us to find out the right of 2.210. So how are we going to determine that right of 2.210 with a 16 degrees of freedom? Okay, degrees of freedom is 16. So as you can see here in this table, this is our T distribution table. The DF is our degrees of freedom, right? So we will have to see for 16. This is our 16, and we will see the right of, means this is 2.120. Okay, 2.120, and the right of it, meaning that from this is our area, this is our probability till the next. Okay, so how much area? So how we gonna determine right of 2.2? So probability for x which is lesser than equals to 2.120. Okay, this is the right portion. So this comes around 0.025. I hope this is clear to you. So let's understand this with the representation. This is our normal distribution curve. The above values are our area probability as mentioned over here. So when the question is asking us right of 2.1210, this is 2.1210 for 16 degrees of freedom. Okay, so in the middle is our 0, this is our positive 1, this is our positive 2, and somewhere here lies our 2.120. So let's consider this point as our 2.120. This side is our left side and this side is our right side. So they are asking the right portion, right of 2.1210. So right portion is this much. How much is the area for this portion? So the area for this portion comes around 0.025 at 16 degrees of freedom. Okay, I hope this is clear. Let's understand the other problem. To the left of 1.337, at 16 degrees of freedom. We know this is our 16 degrees of freedom. Okay, and we will find out 1.337. So here is our 1.337 and the area is showing as 0.10. But let's understand this with the help of a normal distribution diagram, normal distribution curve. So in the middle is our 0, and this, let's assume that this point is our 1.337. Okay, so this side is right side, this side is our left side. We need left of 1.337, this whole complete portion. Okay, but this 1.0 is of only this portion. It always gives us the right side portion. So this is our 0.10. From this point till this point, this whole covered up portion is 0.10. We need the left side of it. So what we'll do, we know that the total normal distribution curve is of 100%, right? Or it is of 1 in decimals. So to calculate the left portion, the left of 1.337, it is going to be 1 minus 0.10. So it comes around 0.90 or 90% probability. Okay, I hope you have got this. This is clear. So the left of 1.337 at 16 degrees of freedom comes around 90%. Let us understand the C to the left of 1.746, left of 1.746 at 16 degrees of freedom. So this is our 16 degrees of freedom and we want 1.746. Okay, so let's draw the normal distribution diagram. In order to understand this, always I have been telling you that to draw normal distribution curve, it helps, it makes us it is easier for us to understand all of the problems with the help of normal distribution diagram representation. So this is our 0, right? And for 16 degrees of freedom, our 1.746 lies somewhere over here. Okay, so as I told you previously, for this for the 16 degrees of freedom and on the point 1.746, we have the area as 0.05, but it always shows us or gives us the area on the right side of it. So this portion is our 0.05. okay, this complete portion is our 0.05. We know that the total is 1 and on this portion is 0.05. okay, so what we'll do, in order to calculate the left of it, we need this portion, the yellow shaded portion. In order to calculate this, what we'll do, we'll subtract 0.05 from 1, we will get 0.95. okay, let's understand the last problem, which is between 2.120 and 2.120. so let's understand what is this. It is saying between either this or this. okay, 2.120 negative, 2.120 positive. So the area lies between this, meaning that we want to calculate this much portion. okay, so how we'll do that? For 16 degrees of freedom, we have a probability for 2.120 as 0.1 0.025. Okay, so we know this total portion is of 1 at this point. So yeah, this much portion is 0.025. So when we will minus this from 1, 0.025, we will get 0.975. Okay, so from this left till this is our 0.975, but we need the only this shaded portion. So what we'll do, we'll again subtract it from 975. What we'll do, we'll subtract 0.025, so we will get 0.95. Okay, so we have subtracted this 0.025 from this portion, so we left with the between portion, which is 0.95. Okay, or to calculate this in different way, what we can do is mathematically multiply it by 2, the area 0.025, we get 0.05, and we can directly subtract this from 1. We are left with 0.95. Okay, this is the other method, and the last method is going to be, we have 1 as our total portion, in the bracket we have 0.025 on the left side, and we have 0.025 on the right side. We'll add both of these, put it into bracket, we will get the same answer, 0.95. So when we visualize this with the help of diagram, what we can see is, on the positive side and on the negative side we have 2.120, this portion, and this portion is our 0.025, 0.025. Okay, and the between, it is asking us between, means the middle portion, the shaded yellow portion, it comes around 0.95. I hope this is clear to all of you. Okay, so let's understand this business case problem. It is saying that sales personnel for Skilling's distribution submit weekly reports listing the customer contacts made during the week. A sample of 65 weekly reports showed a sample mean of 19.5 customer contacts per week. So some data is given to us. We have a sample size as 65. We have sample mean as 19.5. We will write both of these things. Then it is saying that the sample standard deviation. Note the term, which is sample standard deviation, which is given to us as 5.2. Provide 90% and 95% confidence intervals for the population mean number of weekly customer contacts for the sales personnel. So these are our confidence intervals, confidence levels, sorry, and it is asking us to provide the margin of error or the confidence or the interval estimation for both of these parameters. Let's take A case as 90 and B as 95. So we'll first start solving for 90% confidence interval. This is our 90%. Okay, meaning that our alpha is going to be 1 minus 90%. So it comes around 0.1. So our alpha is 0.1. Okay, now let us solve the problem. Step 1 is to calculate margin of error. I'm writing in the short forms as MOE, margin of error. The formula of margin of error is T alpha by 2 into S divided by root n. Why we have selected T? Because sample standard deviation is given to us. Population standard deviation is not given to us. Okay. So T alpha by 2, alpha is our 0.1 divided by 2, which comes around T 0.05 into our sample standard deviation is 5.2 and sample size is 65. So let us check what will be the value of this thing T 0.05. How we gonna check T 0.05 at degrees of freedom we need. Okay, so in order to calculate degrees of freedom, what we do n minus 1. We have sample size as 65. We subtract it by 1, we get 64. So T 0.05 at 64 degrees of freedom we will see in the table. Okay, so we wanted to see degrees of freedom our 64. Okay, and we had T as 0.05. So as in this table 64 is not given to me. So for example, I'm only taking 60 as our degrees of freedom, and just for your understanding, I'm taking 60 as our degrees of freedom. Then what I'll do is I'll see the T for 0.05, this thing. Okay, so on this thing we have 1.671. So T 0.05, 0.05 is our area, right? So for this area, how much is our T value? So on T 0.05, we are getting a value as 1.671. Okay, I hope this is clear. So 1.171 was the value in our table. 1.171 into 0.644. So we are getting the margin of error as 0.755. Okay, so the last step is to calculate upper limit and lower limit. This is our range, right? So normal distribution curve. So to calculate upper limit, what we do is x bar plus margin of error, and in lower limit x bar minus margin of error. So we have x bar as 19.5 plus margin of error as 0.755. Then we have 19.5 minus 0.755. We get the upper limit as 20.255. And we are getting the lower limit as 18.744. Okay, so here is our 18.744 and here is our 20.255. Okay, so 90% confidence interval gives us this interval estimation. I hope this is clear, and I hope you will solve for the 95% confidence interval, which is going to be very easy. The alpha will become 0.05 and alpha by 2 will become 0.025. So T of 0.025 you will check at 64 degrees of freedom and so on. You will calculate the margin of error and then compute the upper limit and lower limit. Let us see you all in the next video. Goodbye.